Okay, so given the question for 25 was a little bit esoteric, I decided to add my own little chi-squared example. This is just a simple business example. And imagine we have Google and they say that they have a pay rise scheme where, 10% get no pay rise, 65% get a standard pay rise, and 25% get a much higher merit pay rise. For example, here, if we had we wanted to kind of sample people to see if what Google is saying is correct. Obviously Google know their exact pay rises, but maybe we're investigating Google and seeing if they really do what they say they do. So we sample 600 people. And these are our expected proportions, 0.1, 0.65, 0.25. So if these are true and we have 600 people, we just have to multiply. So for category none, we've got 0.1 times 600, we'd expect 60. Again, times 0.65, we'd expect 390. And for 0.25, we'd expect 150. Yeah, just multiply by 4 and you get 600. So these are our expected. We have the observed. So the chi-squared is observed. So in this case, B2 minus expected squared all over expected. So for each of these kind of probabilities, we do a partial chi-squared and we add them all up. So this is my chi-squared. It's going to be 19.329. We set our alpha for the test of 0.01, and we set a critical region. So again, we're going from a probability to an actual statistic kind of test statistic value. So we're going to use the inverse function, and with chi-square we use the inverse right tail. And it's going to be the inverse of our alpha value here. And we have 2 degrees of freedom. See, the degrees of freedom, you can literally, you see we have 2 degrees of freedom here. It's literally we have 1, 2, 3 proportions. And we kind of lose a degree of freedom because we calculate a total proportion. All the proportions need to add up to 1, and that loses. So just for a standard goodness of fit, the number of degrees of freedom is the number of categories minus 1. So this is our kind of critical chi-squared value. You see our actual chi-squared is greater than the critical chi-squared. This is our rejection criteria. So we reject if our chi-squared is greater than the critical. And we also reject if our p-value is less than our alpha, which it obviously is here. This e minus 5 just means 10 to the power of minus 5. So this is a very small number here. And here to get the p-value, we're just taking our statistic, and we're using the inverse converts the probability to a statistic. The dist function converts the statistic into a probability, a p-value here. And you see this p-value is very small, so again, we reject. So we say there is enough evidence to reject this null hypothesis that the proportions of our Google employees getting no pay rise is 0.1, a standard pay rise is 0.65, and a merit pay rise is 0.2.